Hi, welcome back to Unit 11, Day 3. We are looking at geometric probability. We are finding the probability of events happening by looking at the favorable outcomes over the total outcomes. We've already done one example with the segment, and so now we're going to pick up reviewing that with these 4 examples using this segment here. Okay, so point M is chosen at random on segment ZP, the whole segment. Find the probability of each event. So the probability that M is on ZQ. So ZQ is 2 out of, we're landing anywhere on ZP. So 2 plus 3 plus 5, that's 2 plus 3 is 5, plus another 5 is 10. So 2 out of 10, which is going to be 1/5. And 1/5 as a decimal times 100 is 20%. Both of these are correct answers. Okay, probability that M is on segment QR. So this time we're going to look at QR. QR is 3 units long. Out of, we can land on the whole thing, 10. 3/10 does not reduce because 3 doesn't go into 10 and nothing goes into 3. So I'm just going to do 3 divided by 10 times 100 and see that it is 30%. So 3/10 or 30% of the time, almost a third of the time, we're going to land in this QR. M is on RP. RP is 5 out of 10. And 5 out of 10 is half, right? Because 5 goes into 5 one time and 5 goes into 10 2 times. And we already know, hopefully, that that is 50% of the time. And last but not least, the probability that M is on QP. So QP is going to be 3 plus 5, which is 8. So 8 out of 10, which is, they're both divisible by 2. That would be 4/5. And 4/5, 4 divided by 5 times 100 is 80% of the time. For my probability that I land on QP. So 80% of the time, I'm going to land anywhere other than this little tiny purple section. Okay, let's look at the next example. Landing. A parachutist needs to land in the center of a target on a rectangular field that is 120 yards by 30 yards. The target is a circular design with a 10-yard radius. What is the probability the parachutist lands somewhere in the target? Okay, so we're landing in a rectangular field. I'm going to sketch this situation that's happening. So we have a rectangle. And in the center, he wants to land in the center of a target on a rectangular field. So somewhere in here, there is a target. The target is a circular design. So we want to land in here. The field is 120 yards by 30 yards. And my target has a 10-yard radius. Okay, so I'm going to need to find 2 areas because to find the probability that I'm going to land in the target, I'm going to have to do the target over the field. Because the target is my favorable, that's where I want to land. And then the field is where I can land. Okay, so let's look at the area of the target. So the area of the target is, my target is the area of a circle, which is pi r squared. And the radius is 10. So that is 100 pi. Okay. Then the area of the whole field, the field is a rectangle, which is base times height. My base is 120. The height is 30. So 120 times 30 is 3,600. All right, so in this one, I don't have any pi's to simplify here. So 100 pi over 3,600, I can't cancel out my pi's, but I can reduce that fraction. 100 divided by 3,600, math, fraction, enter, is 1 out of 36. So it's going to become 1 pi. I'm going to write it down here. It's going to become 1 pi over 36. Okay, I just reduced the coefficient to pi in the 3,600. And then as a percentage, I'm not going to be able to hit math decimal because look at what I'd be turning into a decimal, 1 out of 36. But it's not really 1 out of 36. It's pi out of 36. I'm going to clear that out. I'm not doing 1 out of 36. I'm doing pi under the clear button in blue. Second pi out of 36. When I hit enter, multiply that by 100, and I'm going to get 8.7% of the time. I'm going to land in the target. 8.7% of the time. If I'm just randomly falling or floating, hopefully, to parachuting down to this field. Okay? All right, in the next video, we're going to look at probability using these shaded areas. And then we have a couple extra problems we may or may not get to in that video. It might take us another example. Okay, we'll probably do 2, 3, 4, and 5 in the next video. All right, thanks so much for watching.